everyone and welcome to Edusurg Clinics. I am Dr. Gunjan Desai and today we are going to discuss a topic that has been requested by a lot of our viewers, and that is to have an understanding of MRI in a way that at least you can see the scans and appreciate the findings in an MRI. So we are going to see this topic in 2 or 3 videos, and we are going to see how MRI works, what is an MRI, some concepts of MRI that are important to understand so that you can realize what T1 is, what is T2, what is in phase, what is out of phase. So whenever we see a film, it is a common question that we think about who is the hero of the film. It can be Spider-Man, Superman, Batman. It can be Amitabh. It can be Shah Rukh. It can be a heroine-led movie, right? Similarly, when we are discussing MRI, the one key hero that you need to remember, and the entire discussion on MRI is based on this hero, that is hydrogen. Okay. So out of 102 naturally occurring elements in the world, 26 are found in the human body. However, 96% of our body is made of only oxygen, hydrogen, carbon, and nitrogen. Ionic hydrogen forms the focus of MRI. So when H and H unite by a covalent bond, it is H2. That is not ionic hydrogen. Ionic hydrogen is H1. Okay. So remember that when we say the word MRI, you have to remember ionic hydrogen. Now, where is this maximum studied in MRI? It is water and fat. Okay. So the hero and the supporting actors of this entire series on MRI is going to be ionic hydrogen, water, and fat, right? Now imagine that you are in a school, you see a classroom and you try to walk into the classroom. Before the bell rings, we know that all the children are going here and there. They are not on their bench. They are all doing whatever they want, and that scene looks chaotic. But when the bell rings, and especially when the teacher arrives, all the kids sit in their place, open their books, and start studying, right? This is something that all of us have experienced in our school days and sometimes in college days. Similarly, in our body, when there is no magnetic field, basically when we are just moving around in our body, the hydrogen ions move haphazardly and cancel out the positive and negative charges. What that means is that if this arrow is positive, this is negative, you will have an opposite hydrogen ion movement which will cancel out this charge. So the net charge in a body is zero. Okay. So when we say that this guy has a magnetic personality, well, actually it is not possible unless that person is an MRI. Okay. So you cannot be attracted to a person because the net magnetization vector of any human being outside a magnetic field is zero. Jokes apart, when we give an external magnetic field to this body, the protons align, and most of them align parallelly to the magnetic field, whereas some of them align anti-parallel. Okay, so this proton alignment is basically what the magnet of the MRI will do. Magnetic current has been given from bottom upwards, and you can see that most of the hydrogen ions will align parallel to the direction of the current, whereas some of them will align in the opposite direction. So what does the magnet of an MRI do? We know it is magnetic resonance imaging. So the first component of the machine is a magnet. The magnet aims at proton alignment. So when we hear the terms like 1.5 Tesla or 3 Tesla, these are basically the external magnetic field of an MRI. So when the body goes inside the machine, the first thing that happens is this magnet causes alignment of the ionic hydrogen in the direction in which the magnetic field is applied. So if it is an open magnet, there is less field strength and there is less claustrophobia. If it's a closed magnet, which is the commonly seen MRI machine, most systems are closed machines, there is more field strength, but there is more claustrophobia. So you see here that once the patient goes inside the machine, the external magnetic field is applied in the direction of this black arrow, and then the patient's magnetic field will also align with this magnetic field, that is the external magnetic field. So MRI, the concept of M is over here. There is a magnet in the MRI of the strength 1.5 Tesla or 3 Tesla or whatever your machine strength is. And this magnet intends to do proton alignment so that the current in the body is in the direction of the external magnetic field. Now going to the next concept, and you all have spin the top in your childhood. Think of a spinning top. When you spin it, you can see that it spins, that it's going round and round, but it is also wobbling. What that means is that the central axis at one end also keeps moving. This is because you gave it a spin. Similarly, imagine a tire that you have been playing with in childhood. Hydrogen protons are also naturally spinning in our body randomly. Now, when we apply the magnetic field, that is the M of MRI, that's an additional force to spin. Okay, and what happens is they will spin and wobble in circles around the main magnetic field. This wobbling movement is basically precession, and that causes the magnetic moments to follow a circular path around the magnet. What this means is that when the hydrogen ions align in direction or completely opposite to the direction of the magnetic field, they also precess in that alignment. What that means is you can see here it is spinning around this axis, but the axis is also moving. You see this blue top that's moving, that is precession. So it's spinning here, but the axis also keeps moving, right? That is known as precession. And it is at a frequency that is at some rate of cycles per second. So, like a spinning top, when the magnetic field is applied, it causes one, that is proton alignment. But when that proton alignment occurs, the atomic nuclei also precess. And this precessional rate of atomic nuclei or the wobbling of the nuclei along the z-axis is known as Larmor frequency. That is the rate at which the atomic nuclei, basically the ionic hydrogen, wobble or precess around the main magnetic field in the MRI scanner. So for example, if it's a 1 Tesla magnet, the Larmor frequency of hydrogen is about 42 megahertz or 42 million cycles per second. What that means is that in the z-axis, that is along the patient from foot to head in our diagram, the ionic hydrogen is also wobbling at Larmor frequency. And this is important to understand because when we go to R, that is the resonance part of MRI, the resonance can only happen when something matches Larmor frequency. Okay, we will look at some examples of this. But at this point, I hope you have understood what the M of MRI stands for. So it is a magnet. The magnet causes proton alignment and it also causes the protons to move at Larmor frequency. So two purposes of M. Okay. Now we go to resonance. So if you don't know what resonance is, welcome to the swing. I am sure all of you have sat also. Some of you have done what the lady is doing to the kid. Now understand that when you apply small pushes at regular intervals that matches the natural rhythm, the swing goes higher and higher. What that means is that the amplitude will keep increasing dramatically till it reaches its maximum point. So rather than giving jerky movements which do not match the natural rhythm of the swing, if you push it in its natural frequency and just give small nudges, you will see that the swing goes higher and higher. Similar, another example is tuning a radio. If you tune a radio, basically what you are doing is you are adjusting the resonant frequency of the internal electric circuit in the receiver. So when the circuit's frequency matches the frequency of the radio station, that is when the resonance happens, and that resonance of a specific channel is the sound that we hear clearly, right? So basically, resonance is there in our life. As doctors, I am sure you have seen a tuning fork. When you use two tuning forks, you slap one, it produces a sound, but if you stop it and the other one's close by, the other one starts moving, right? That is also resonance. So it is energy transfer or increasing energy when the frequency matches. So tuning a radio, the radio station's frequency has to match to the radio circuit frequency. Swing, the flow of the swing has to be the same. A very simple example that is given commonly is an opera singer who can break a champagne glass by her singing. When will that happen? That will happen when her sound frequency matches the vibrating frequency of the glass. So accumulation of energy keep happening to the breaking point, and that is when the glass breaks. So basically, resonance is you are increasing or exciting the natural frequency by matching the natural frequency of the substance, whether it's a swing, whether it's a radio, it's opera singer or a tuning fork, right? So that is what is resonance. So why is this important? This is important because the R of MRI is resonance. So if you understand what resonance is, apart from physics, it's frequency matching frequency, right? So if you connect to a person, you say my frequency matches with that person, suddenly the good hormones increase, you get excited. That is basically also resonance. You resonate with someone, right? So radio frequency is a type of electromagnetic alternating current with a frequency range which is typically matching the radio frequency spectrum, that is 9 kilohertz to 300 gigahertz. But actually the radio frequency pulse that is used in MRI machine for resonance is an electromagnetic alternating current. So RF pulse, remember this term because it's going to come up repeatedly. We are talking of resonance. We are talking of causing resonance to ionic hydrogen. So RF pulse is given at a frequency, and this frequency has to match the precession frequency. That is the ionic hydrogen's Larmor frequency. Because as I said, only if the frequency matches, resonance can happen, right? So RF pulse is given at a frequency which exactly matches the precession frequency that excites the protons or knocks them out of their position. Why is this important? Because when this pulse stops or when the sequence of this pulse stops, the protons will come back to their position by releasing the extra energy that they gained by resonance. And it is this released energy that we are capturing by the receiver in the coil, and that is known as signal. Okay, the signal comes at a specific time, and noting the signal and the time is what creates the imaging. Okay, so M is the magnet. Magnet causes the proton alignment and the precession movement. That movement is occurring at Larmor frequency, specific number of cycles per second. When you give an RF pulse that matches the Larmor frequency, that excites the protons and knocks them out of park, when the pulse stops, there will be a time when they come back to their normal position. But for that, they have to emit an energy. That energy, when taken by the receiver and processed, the signal and time is what is going to give you the image. So when the RF pulse frequency is equal to Larmor frequency, resonance happens. Okay, so that is basically the concept of magnetic resonance and image generation. So MRI, I hope that is clear now. Just to show in our diagram, remember that everything's done in three axes. The Z axis is along the patient. The X and Y are perpendicular to the patient. So z-axis is actually the axis of baseline magnet. When you give the RF pulse, the protons, once the pulse matches the Larmor frequency, the axis of the body ionic hydrogen changes and it follows the direction of the RF pulse. So if pulse is given from above, the receiver will be below and it will receive this signal when the pulse stops and the protons return back to their normal and emit an energy. Okay, so this is basically the pulse that is happening. This is one pulse. Okay, when you add another pulse, then one more pulse, there is a sequence of pulse that is happening. There is a gradient between the MRI, the magnet, and the RF coil, and this is what produces the image. Okay, so it is going back to resting state of the protons that have been excited by RF pulse, which produces the image. So understanding the coil, we have all seen the machine, but if you break down the machine, there is a magnet, like I said, there are gradient coils to change the gradient of the magnetic field beyond the scope of this lecture. And you have the radio frequency pulse coils, which generate the sequence of pulse as well as receive the signal. Okay. So magnetic coil in different directions, like I said, you have X coil, Y coil, and Z coil. RF coil for delivering the pulse as well as receiving the signal. And you do spatial encoding in X, Y, and Z axis. We will see some of it in the next video, but not in detail. But these are the signals that then produce the image. Okay, so to summarize, ionic hydrogen is the focus of MRI. In body without a magnetic field, they spin randomly, and that is why human body is not a magnet. Given an external magnetic field, they align at precessing frequency, that is known as proton alignment. When you give RF pulse at Larmor frequency to protons which are already precessing, they experience an energy boost. This excitement causes them to go out of their path. When the pulse stops, energy is released, and that helps them to come back to their resting state. This release and realignment event is spatially encoded in MRI, and that is what produces the image. So this is written in your books. These simple 4 lines are written in the books, but it is very important that you understand these concepts so that when we study the sequences in the next part, you will see why T1 is something that is different from T2. And you will understand these, at least these 4 terms: magnet, resonance, Larmor frequency, radio frequency, pulse, and T1, T2. All these things are basically pulse sequences. Okay. So that is what you have to understand. So that is basically this machine that you see in your hospital, the MRI machine. Now, like I said, we want to learn the sequences and why various sequences have been generated. And this is something that we need because we want to see liver MRIs and we want to see rectal MRIs. And you will see these many plates in the folder of MRI. And the simplest thing you will do is read the report. But in the next part of this series, that is the sequences, you will see what is T1, what is T2, what is in phase, out of phase, fat set, and the triphasic contrast, which is more or less like CT scan, and heavily weight T2, which is the MRCP. So these are the sequences that are basic when you want to learn MRI, and we will see that in the next part. Thank you.